Hey everyone, this is the video to accompany your distance learning packet for the week of May 4th. So this week we are looking at traits and inheritance, which means how are traits passed down from parents to offspring. So last week you learned about traits and variations in traits, and that some of them are hereditary, meaning we get them from our parents. So let's say you have a parent with brown eyes and you have a parent with green eyes. How do you know if you're going to get brown eyes or green eyes? Well, these are questions that scientists had too. How are traits passed down from parents to offspring? So one of the ways that they figured this out was by studying some simple organisms, and one of them was fruit flies. So fruit flies have differences in traits, and one of the differences is the colors of their eyes. So that's what you're looking at in activity 1. So activity 1 asks you to get 2 containers. They could be cups or they could be bowls, just 2 containers, and to label them parent 1 and parent 2. And then you need to get some paper. I just cut up some index cards, or you could get some scrap paper. And you're going to draw 2 red circles on 2 of them, 1 on each. And then you're going to draw 2 white circles. So this is going to represent the genes, 2 copies of the genes for red eyes and for white eyes, okay? So we are going to put the 2 red copies of the gene into parent 1. We're going to put the white copies of the gene into parent 2, okay? And this is the table that you have in your packet. I've just made it bigger for you. So now what you're going to do is close your eyes, select 1 card from each of these cups. And as we can see, we have a red and a white. So on your chart, you're going to draw a red eye and a white eye. And you're going to do this 3 more times, okay? You're going to put them back in the same container, and you're going to draw them out 3 more times. Well, we've only got red in here in parent 1, and we've only got white in parent 2. So as you have probably guessed by now, every single time we do this, we're going to draw out 1 red from parent 1. We're going to draw out 1 white from parent 2. Now, does that mean that all of our offspring are going to have 1 red eye and 1 white eye? That really doesn't make much sense. If you think about animals and what you see in nature and humans, it's pretty rare to see them one with 1 color eye and 1 with another color eye. It does happen occasionally, but it is a rare occurrence, okay? So maybe there's a different explanation for how this will look. So for now, we're gonna leave the offspring appearance, we're gonna leave that column blank, okay? All right, so for table 2, we're going to change up these cups a little bit, okay? So we're going to put a red and a white in parent 1 and a red and a white in parent 2. And I'm going to introduce 2 terms to you. The first one is dominant, and the second one is recessive, okay? So if a parent has 2 alleles or 2 copies of the gene for red eye, you would expect they're going to have red eyes, okay? If they have 2 copies of the gene for white eyes, you're going to expect that those eyes are going to be white. But what if they have 1 copy of each? Well, in fruit flies, the red gene is dominant and the white one is recessive. So that means when you have 1 of each, the dominant gene kind of covers up or hides the recessive gene, and you only see the dominant gene. So if I have 1 of each, that fruit fly is going to have red eyes, okay? So we're going to have parent 1 who has red eyes, but has a dominant and a recessive gene, and parent 2 who has red eyes, but also has a dominant and a recessive gene, okay? And now in table 2, you're going to draw 1 card from each and see what you get, okay? And as you can see in your chart, there's 3 different possible combinations for what you could get. You could get 2 red, you could get 2 white, or you could get 1 red and 1 white. Those are the 3 possibilities of what you could get. So you're going to do this 12 times and see how many times you get each one. And if you do it right, what you should find happen is that you get about 6, which would be 50% of offspring, 3 and 3. Okay? So what this means is about 50% of the offspring are going to carry a red and a white gene, but remember we said that means that they are going to have red eyes. About 25% of the offspring are going to carry 2 red genes. They're also going to have red eyes. And then 25% of the offspring are going to carry 2 white genes, which means they're going to have white eyes. So I've got 75% of the offspring should have red eyes, and 25% should have white eyes. Okay? Now, the way that scientists figured this out by doing all of this trial, they then created a Punnett square, which is what they use to determine possible combinations of what you could get from parents. So the way a Punnett square works is you have a square on your paper and you're going to have one parent at the top and then you're going to have one parent at the side. So let's say that we have parent 1 on the side, and parent 1 has 2 red eyes, just like in our first example. And parent 2 is on the top, and parent 2 has 2 white eyes. The first square here is going to get 1 allele, or 1 copy of the gene from parent 1, and it's going to get 1 copy of the gene from parent 2. Okay? And then we do the same for each square. We get 1 copy from parent 1, 1 copy from parent 2. Okay? And you can see from this, our results are the same as the first activity that we did, where all of the offspring had the red and white combination, which we now know is red eyes. Okay? So if you have a parent that is carrying 2 dominant red copies of a gene, then all of the children are going to have the red eyes. Okay? Usually though, when you're making Punnett squares, you don't use colors and circles to represent. They usually use letters to represent. So in this example, the capital R represents the dominant gene, the red, and the lowercase r represents the recessive gene, the white. Okay, so this is just another way of showing you with letters what I just showed you with the colored circles. Okay, let's try a different example where we have 2 copies that have a red dominant and a white recessive for the 2 parents. Okay. So again, right here we're going to get 1 gene from parent 1, 1 copy, and 1 from parent 2. In this square down here, from parent 1, I'm going to get the white copy and the red from parent 2. Up here, I'm going to get the red from parent 1, the white from parent 2, and then down here, I'm going to get a white copy from both, okay, from parent 1 and parent 2. So this is showing you the second example. So if you look here, we have 25%, we're going to have 2 red copies, 50% are going to have the red and the white, because I've got 25 here and 25 here. And then 25% are going to have the white copy, okay? So that means if I'm looking at this, I've got 75% are going to have red eyes. These 3 are all going to have red eyes. And 25% are going to have white eyes, okay? And if you want to see what that looks like with letters, I have my two parents that are carrying a dominant and a recessive gene each. This is the red, this is the white. So in this first square, I get two capital R's. In this bottom square, I get a capital R from the top, a lowercase r from the bottom. In this square, I get a lowercase r from this top parent and a capital R. And then the bottom square, I get two lowercase r's. Okay, so this is showing you the same thing, just with letters instead of with colored squares. Okay, so take some time reviewing that and practicing Punnett squares, and then answer the summary questions in your packet. Thanks.